Okay. If two of the 5 labeled angles are chosen at random, what is the probability that they are supplementary? Well, a supplementary angle adds up to 180 degrees. So I wonder how many supplementary angles we have here. For this problem, they don't want just the obvious supplementary angles. I almost made that mistake. They don't just want angle 1 and 2, what's the probability of choosing angle 1 and 2, and what's the probability of choosing angle 2 and 3. Those are obviously supplementary. But this geometric configuration allows for many more angles here to be supplementary. You've got, you've got 3 and 4. They are supplementary because they're interior angles, cut by two parallel lines cut by a transversal, and the interior angles on the same side are supplementary. That's a theorem. So you've got 1 and 2. Let's see. You've got 1 and 2. You've got 3 and 4. You've got 2 and 3. 1 and 2, 2 and 3, 3 and 4. And also, since 3 and 1 are vertical angles, well, we already did that one, so let's hold off on this side. Let's start to move over here. Since 4 and 5 are vertical angles, and vertical angles are equal, well then, since 4 is supplementary to 3 and 4 is equal to 5, then 5 must also be supplementary to 3. So that's one there. And since 4 and 2 are corresponding angles, because, two parallel lines cut by a transversal, corresponding angles are congruent. 4 and 2 are both to the right of the transversal, and both of them are above their respective parallel line. So 4 and 2 are congruent. Well, if 2 is supplementary to 1 and 4 is congruent to 2, then 4 must also be supplementary to 1. So that's another one that we can add to the mix. So let's see if there's any more. So if 4 and 1 are supplementary, which we just showed down here, they are supplementary, and 5 is equal to 4 because it's a vertical angle, then 5 must also be supplementary to angle 1. So that's another one. So that's 1, 2, 3, 4, 5, 6 circumstances where we could have supplementary angles from these labeled angles. So that's kind of like one of the first things you have to do in these type of probability problems, because these are the type of probability problems where we have to start counting all the possibilities. And now we have to try and find what are all the possibilities of choosing 2 out of the 5 angles, because we could choose many, not just these supplementary combinations. There's many other ways to choose 2 out of the 5. And we call that a combination, and we usually write it like this: the number of ways to choose 2 things out of the 5. But we're going to just do it manually. This is something you can put in your TI-84 or TI-83 calculator, but we're going to count these possibilities manually. And now this is going to go in the denominator for our probability. So all the possible ways to pull 2 angles out of the 5. Well, we can pull angle 1 and angle 2. We could pull angle 1 and angle 3. We could choose angle 1 and angle 4, angle 1 and angle 5. And then we can choose angle 2 and angle 1, but we already said that. And we're not going to have any repeats. So there's going to be no repeats here. And order does not matter. Okay, so let's keep going. So we did all our 1s. 2, we already have 2 and 1 up here. 2 and 2 we can't have because we've already pulled out 2. We can't repeat it again. But we can pull 2 and 3. We could pull 2 and 4, 2 and 5. And then now the 3s. We could choose 3 and 1, but we already have 3 and 1. 3 and 2, but we already counted that. 3 and 3, we can't count that because we've already pulled 3. 3 and 4, and 3 and 5. Okay, then 4. 4 and 1 we already did. 4 and 2 we did. 4 and 3 we did. 4 and, well, we can't have 4 and 4 because we've already chosen 4. But we can have 4 and 5. And then if we started with 5, well, I think we've already exhausted all of our 5s. We have 5 and 1, 5 and 2, 5 and 3, 5 and 4, and we can't have 5 and 5. So the 5s are done. So these are all the possibilities of choosing 2 out of the 5 angles. These are all the different possible ways that we can count this is actually what we call counting, where we're counting all the possible outcomes of choosing 2 out of the 5 angles. So how many possible outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 possible outcomes, and that's what goes in the denominator of our problem. Okay, so since we know now that we want to have these 6 outcomes, well, how many times do these outcomes occur? Well, these outcomes occur, the 1 out of 2 occurs here, and the 3 out of 4 occurs here. I mean, they occur 6 times. The 2 out of 3, the 2 and 3 are here. The 5 and 3 are down here. The 4 and 1 is there. And the 5 and 1 is here. So we can see that out of the 10 possible outcomes, the supplementary ones occur 6 times. 1, 2, 3, 4, 5, 6. So there you have it. So that reduces then 2 goes into 6 3 times and 2 goes into 10 5 times. So that is our probability that if we chose 2 angles out of these 5, the probability that those 2 angles would be supplementary is 3/5.